Now, recently we worked on exercise set 6.6, where we had some matching, which we would then say, well, what would be the next step in solving these examples? And we did that in an earlier lesson, but I thought it might be good, since we saw the next step, how do we solve it and what would the answers be? So we'll do these. So here we see it's in its exponential form, and we said the way to solve this was to put it in its logarithmic form. So we then went log of 5 to the x power equals the log of 3. So we've just converted it from its exponential form into a logarithmic form. But now we have this exponent. Well, we saw from an earlier lesson we can take this exponent and put it out in front here. Now that we have x in the equation line, we then solve this by dividing both sides by the log of 5. And these then cancel out, and we get x equals, now we put this into our calculator, log of 3, you have to put it in parentheses, divided by log of 5, and the answer comes out to 0.68260. And if we're to round it to 4 decimal places, we look at what's in the fifth, drop this, and that's our answer. And again, we should use wavy lines since this is an approximation. Go right on to example 2. Again, this is in exponential form, but it's the natural log e. So we'll put that in its form, natural log of e to the x power equals 3. Well, I should say natural log of 3. Now we're going to take the x from here, put it in front, so it now becomes x natural log of e equals natural log of 3. Now, an interesting thing happens when we have this combination right here, because natural log is of e, and having this arrangement, natural log of e, but base e, this item right here just becomes a 1. So this would be in a sense to the first power. So we then have x, this is a 1 that I'm not going to write, equals the natural log of 3. And you put that into your calculator. And I see I didn't copy this down correctly. There's supposed to be a 5 there. So there's a 5 there. There's a 5 there. So we have to divide this to get rid of the 5. So we have to divide this by 5. Okay. Sorry about that. I didn't copy it correctly. So here the 5 canceled out. This is just a 1, so I'm left with just the x. This is the little tricky part. So we put that into our calculator. Now remember, this would be the exact answer. But when we put into our calculator, we get 0.21972. And again, we're rounding it to 4 places. So we look at the 5th place, it's a 2. So we drop that, and then this is our answer. All right, looking at example 3, we're going to put this from its logarithmic form into its exponential form. So what is our base of the natural log? It's e. This is our exponent, which is 3. And the answer, we said, is always what's there, x. So this would be the exact answer. And if we put that into a calculator, e caret 3, it comes out approximately 20.0855. With a 3 in this 5th place there. Again, we just drop that. And this is our answer for number 3. Now, for number 4, again, it's in its logarithmic form. The next stage that we use is its exponential form. So our base is 5. Well, let me go back for a moment. No, our base is x. Our exponent is 3. And our answer is 5. Okay, now we're in better shape. Now, to actually do this one, there's a couple of ways to do it. But I think the easiest way is just take the 3rd root of this side and the 3rd root of 5. Little phone call coming in. So the 3rd root of x to the 3rd is x. And then the 3rd root of 5 is 1.70997. So again, if we're going to round that off, we would raise this to 1, then this goes 1, and this becomes then 1.7100. And that would be approximate. Okay, so there are the first 4 worked out. I was thinking I would put the bottom 4 in here, but that would really jam it up. So if you need to go over any of these, pause it, because we're going to pause it and go to the last 4 examples. Well, we'll work on these 2. But notice this is the logarithmic form in which it's spread out. And if you find something like this, you convert it to the more condensed logarithmic form, which is log base 5 of x times this and the way they had it in our textbook for matching was log base 5 of x squared minus 2x equals 3. And we could put that in parentheses if we'd like. Now we're going to convert it from its logarithmic form into its exponential form. So the base is 5. The exponent is 3. And this is the answer. It equals x squared minus 2x. So now we have sort of a quadratic equation. We want to expand this to 125 equals x squared minus 2x. Going to bring this 125 over to this side as a negative 125. And we can just erase it there. And that's equal to 0. Now this doesn't factor, and the only way we could do it, we could try completing the square or just use the quadratic formula, where our a term is 1, our b term is a negative 2, and our c term is a negative 125. And you put that into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and that gives you your answers for this one. For number 6, it's a little different because it being addition, it's subtraction. So we write this in the condensed form, log base 5 of x over x minus 2. And that equals 3. And the way to do it is to put it in its logarithmic form. Our base is 5. Our exponent is 3. And that equals x over x minus 2. We expand this becomes 125 equals x over x minus 2. And here we cross multiply. We get x equals 125x minus 250. Now, a couple of ways to do it. We could move this x over to this side because this then becomes a 124x. Move this over to this side, it becomes a positive 250. And we then divide both sides by 124. And that gives us our answer. And I do have an approximation of this as 2.016129. And if we're going to round that off to 4 places, 1, 2, 3, 4, we would just drop that. Also, this could be given as an fraction. Divide this by 2, that's 125. Divide this by 2, that's going to be 62. Now this would be an exact answer, not wavy lines, equal signed. And this would be the approximate answer if you just did your division there. But that's the method of getting the solution to these quadratic, in some cases using the quadratic formula, or just converting it from its logarithmic form to its exponential form to solving it. And these, of course, are quite challenging. Let's go to our last two. Now, as we look at this one, it's natural log, so they're not writing the base in there, but we could. We could put a letter E in there, and the letter E in there, so that when we put it into its condensed form, it's letter E, and then this is going to be a fraction x over x minus 2 equals 3. So we're just, instead of writing it out with the E in front each time, I put it this way. So now, putting it into its exponential form, our base is E to the third power, and that's going to equal this. This is the answer. Now, this is over 1. And again, we can kind of cross multiply, or we can get a value for this. But if you just put this into your calculator, the numbers are just big here. So e to the third, you put that into the calculator, gives you this, which equals that. And then this is over 1. So I'm going to multiply this side, which I illustrate here, and that equals x. So I distribute, get this, subtract an x from both sides and get this, move this to the other side, it becomes positive. Now I divide both sides by this, I get an answer, x equals 2.10479, that if we were going to round off, we drop this and make the 7 and 8, rounding it to 4 decimal places. Again, they didn't ask you to do these here, but those were the examples they gave. What would be the next step? Okay, now for this one, we had one very similar to this, except it was log base 5. Here there is no base appearing. When that happens, the base is 10. So we're going to summarize this. Log base 10 of x times x minus 2 equals 3. We're going to distribute log base 10 of x squared minus 2x equals 3. Now I'm going to put it in exponential form. My base is 10, my exponent is 3, and my answer is this. Now I'm going to expand this. This becomes 10 to the third is 1,000. But I'm going to move over to this side as a negative 1,000. And now this becomes a 0. And we're going to use the quadratic formula to solve it. Our a is 1, our b is negative 2, and our c is a negative 1,000. And that gives us our answers. Again, you're going to use the quadratic formula. Okay, but our key role here was to show you, they gave you the second step. What do you do with the second step to solve it? And this is proof of the pudding, so to speak. Okay, just under 20 minutes.